All right, welcome. We're about to dive into a pretty incredible high-speed journey. We're going to follow a single, simple message from your keyboard all the way to a friend on the other side of the planet, and it all happens in less time than it takes to blink. Let's get into it and see how it all works.
I mean, have you ever really thought about it? You type hello, you hit that send button, and poof, it just appears on a screen thousands of miles away almost instantly. It feels like total magic, right? But it's not. It's actually a brilliant step-by-step process. And in this explainer, we're going to follow that message every step of the way.
So the very first step on our message's big adventure is translation. Before your hello can even think about going anywhere, it has to be changed from our human language into a language that computers can actually, understand. Let's start on familiar grounds. We humans operate on a system called denary, or base 10. It's just what we learn in school. We've got 10 digits, 0 through 9, and we put them in columns. The ones column, the tens, the hundreds, you know the drill. It's totally second nature to us. Computers, though, they are built completely differently. They don't have 10 fingers. They just have billions and billions of tiny little switches that can only be in one of two states, on or off. That's all they've got. So they use a system that perfectly reflects that reality. Base 2, also known as binary. It only needs two digits, a 1 for on and a 0 for off. So what this means is that every single character in your hello has to be converted into a unique 8-digit pattern of these ones and zeros. The H gets its own pattern, the E gets another, and so on. This little 8-bit sequence is called a byte, and it's basically the fundamental atom of all digital information. Everything is built from bytes.
Now, as you can probably imagine, staring at these massive strings of ones and zeros would get pretty confusing for us humans really fast. And that's where another system, hexadecimal, comes in to save the day. Just think of it as a super convenient shorthand for binary. If you've ever messed with website design and seen a color code like hashtag FF0000 for a bright red, well, you've used hexadecimal. It's just a much cleaner way for people to write and deal with those long binary codes underneath.
Okay, so our hello message is officially a stream of zeros and ones. But now what? What happens next? Well, now it's time for the computer's brain to actually take over and figure out what to do with these instructions.
And that brain is the central processing unit, or the CPU. This thing is the engine of the entire computer. It does all the heavy lifting, all the calculations, the decision-making, you name it. This is the spot where that raw binary data gets turned into actual, meaningful action.
Now, what's really interesting about this slide is that at the absolute core of everything the CPU does, there's this simple, constant, three-step rhythm, the fetch, decode, execute cycle. You can think of it as the heartbeat of all computing. The CPU fetches an instruction, it decodes it to understand it, and then it executes it. And it repeats this loop billions of times every single second. It's this relentless cycle that makes literally everything on your computer possible.
So our message has been translated, and it's been processed. Now it's finally ready for the most exciting part of its adventure, the journey across the internet, this vast, kind of chaotic network that connects billions of devices all over the world.
See, you can't send a long message all in one go. It would be like trying to mail a whole book in a single envelope. It's just not efficient. Instead, our binary hello gets chopped up into these tiny, manageable pieces called data packets. Think of them like digital postcards. Each one is a small part of the bigger message, and they're all ready to be mailed on their own. And each of these little packets is perfectly organized. It has three key parts. The header is like the mailing address. It's got the sender and receiver's IP addresses. The payload, that's the good stuff, the actual piece of our hello message. And then the trailer has some error checking data just to make sure the packet arrives safe and sound without getting corrupted. This whole brilliant system is called packet switching. And instead of forcing all the packets to go down the exact same road, they can all take different routes through the network to find the fastest path. It's like a massive interstate highway system for data. Routers act like traffic cops, pointing each packet where to go. Then, once they all arrive at the destination, they get reassembled in the right order, and our hello is whole again.
Okay, so our packets are racing across the public internet. But this journey, well, it's not without its dangers. The internet is a public place, right? So how do we make absolutely sure that our message gets there without any errors, and more importantly, without being read by somebody it wasn't meant for?
The answer is one powerful idea: encryption. This is basically the process of scrambling our message into a secret code, which we call ciphertext.
It's kind of like writing our digital postcard in a secret language that only the person it's for knows how to read. Without the right key, that encrypted message is just total, meaningless gibberish. And there are two main flavors of this. There's symmetric encryption, which uses one single secret key to both lock and unlock the message. But the one you see most often online, the real workhorse, is asymmetric. This is a super clever system that uses two keys, a public key that anyone can use to lock a message, and a private key that only the recipient has to unlock it. This totally solves the problem of how to share a secret key in the first place, and it is the absolute foundation of modern internet security.
So, let's recap. Our hello was translated into binary, processed by the CPU, chopped up into packets, sent securely across the entire globe, and then put back together again. It's an amazing journey for sure, but the principles behind it, they're the foundation for so much more.
Just think about it for a second. The logic of binary data, the raw processing power of the CPU, the structure of how we send information across a network, these aren't just for sending messages. They are the fundamental building blocks for literally everything digital, from the giant databases that organize the world's information to the artificial intelligence that is actively changing our future.
And that right there is the biggest takeaway from this whole journey. All of the incredible complexity we see in modern technology, our smartphones, the internet, even AI, it isn't magic. It's all built from simple, logical, and kind of elegant rules, just like the ones we've been looking at, just applied at a mind-boggling scale and speed. It's just really, really clever engineering.
So you've now followed the epic journey of a single hello. You've seen the fundamental building blocks of our entire digital world. So the only real question left is, now that you understand the rules, what are you going to build with them?